And the quiz on Monday will have you drawing, counting electrons, and everything up to exactly what we did yesterday. If you have any questions as we go through this homework, please make sure you ask. The other thing is it will have you tell the shapes and angles. Now, normally this quiz would be taken where students had to have that stuff memorized. This one, obviously, since you'll be taking it home, I can't monitor that. So since we know that some people will be gross, we'll let everybody just look at their thing. Right? You can use everything you have. So let's take a look without further ado. Can you guys see that okay? Nope. I need to share the screen. Boom, boom. So let's take a look at what you've got here. Carbon is unique, meaning it's the only one thing there. So we're going to put it in the center. We're going to place CLs around it. Carbon gives off 4. Each CL gives off 7. 7 times 4 is 28. And that's a total of 32. 2, 4, 6, 8. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. If we take a look, the number of atoms bonded to it, well, there are 4 chlorines bonded to that carbon. We scan the carbon and all we see are bonds on it. So there are no unshared or lone pairs. If we look at the back of that table, we find 4 bonds and 0 unshared pairs. We see that that is a tetrahedral arrangement. And that also is a tetrahedral shape. A lot of things can have the tetrahedral arrangement. Anything where this plus this, these two added up equals 4, that's a tetrahedral arrangement. The only one that has a tetrahedral shape is when you have 4 bonds and 0 unshared pairs. For example, if you had 3 bonds and 1 unshared pair, that would still be tetrahedral, but it would shape-wise, it would be trigonal pyramidal. Now the bond angle for tetrahedral is 109.5. So here, arsenic is in the center because it is unique. We have hydrogens all about it. Arsenic is 5 plus 3 from the hydrogen is a total of 8. So we have 2, 4, 6, 8. Counting the bonded atoms, there are 3 bonded hydrogens to this arsenic. We have this lone pair right here that is not a bond. Again, 3 plus 1 is 4, which is tetrahedral in arrangement. But as I said, 3 bonds, 1 unshared pair. We look at that. We see a triangle and we see a pyramid. So that is trigonal pyramidal. And that's it. H2SE. SE is 6. So here we have 6 plus 2 is 8. 2, 4, 6, 8. 2, 4, 6, 8. And take a look at that. What does it look like the angle is for this? Looks pretty straight across, doesn't it? Right? So you might think that's 180. Well, we have 2 bonded atoms and 2 lone pairs. That's a 4 again. So this is tetrahedral again. What did you find for the shape there? I'll open up the chat if you want to type it instead of say it. But what has 2 bonded atoms and 2 unshared pairs on the back of this sheet? Go to the back sheet and find 2 bonded atoms and 2 unshared pairs. I'll get a drink while you do it. Anybody at home? Anybody at home? Got it. Mhm. You can type it in once you get it. 2 bonded atoms and 2 unshared pairs.
Is it angular?
It is angular. Nice job, Sydney. So angular. Does this look like it has an angle though? No. But we know if we look, it should have an angle of 104.5. What that means is we're looking at this up and down. All of these are lined up. 1, 2, 3. So it looks like it's flat. It looks like no angle. But if we were to tilt it a little bit, we would see that 104.5. And what does this mean? This means that these drawings are not representative of the actual shapes three-dimensionally because a piece of paper is flat. That means that you can't really judge the angles on this. Well, what does that mean? Well, that means that whenever you look at this, you can't just say, oh, it looks straight. So its angle is 180. You've got to identify 2 bonds, 2 unshared pairs. Go to that information sheet and say, oh, this is angular. Its angle is 104.5. We can't use our own sight to judge it. In reality, what are the angles here? Well, the way I've drawn it, it looks like 120, right? Because 120, 120, 120. But when we go and look at the sheet, it says, well, this is trigonal pyramidal. So each angle is 109.5. So we got to look at those things. We can't just judge by the picture we see. BEH2 was optional. Let's see why BEH2 is optional. BE is in the middle.
Monday at 4 p.m. Okay, then I'll take that.
So we have BE in the middle. We have H's here and here. You take a look. BE has a total of 2 valence electrons. Each H gives 1. So it's a total of 4. How many am I showing here? 4. I have no way to get more than that. So that means that we are done there. BE is an exception, just like boron. It's done with 4. We can't do anything better. So that means that how many atoms are bonded to the BE? That is 2. How many lone pairs do we have? 0. What has 2 bonded atoms and 0 unshared pairs? What is the shape of that? That is linear. And what is the shape, or what is the angle of linear? Straight line has what angle? 180. 180. Good. Here we have CO2. Unique, C is unique there. So we have CO2. 2, 4, 6, 8, 10, 12, 14, 16. 4 plus 12 is 16. So we end up with double bonds here. Now I want to reinforce what we talked about yesterday. When we talk about the number of atoms bonded, we don't count these bonds. We talk about the bonded atoms. There's 2 oxygens bonded to that carbon. So that's a total of 2 right there. 2 bonded atoms. How many unshared pairs? We're only looking at the carbon. How many carbon unshared pairs are there? There are 0. Again, 2 bonded atoms, 0 unshared pairs. That is linear. And that is linear 180. Yesterday we talked about if they have a charge. If the charge is positive, we subtract from the total number of valence electrons available. If the charge is negative, we add to it. So if we take a look, S is unique. We're going to bond some oxygens all around it. We get 6 times 5, which is 30, plus 2, which is 32. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. For 4 bonded atoms and 0 unshared pairs. As we said, the shape of that is tetrahedral. The electron arrangement is tetrahedral and the shape is tetrahedral. And that is angle-wise 109.5. Questions so far? Everybody good? Any questions so far? Brianna? No? Absent. Let me get this attendance real quick. Cassidy is here. Gooch? Absent. Kennedy. Harris is here. Amani is here. Here. Sydney is here. Kyle's here. Anna's here. Landon? Landon? Here? All right. Good, good. All right, let's do this last one. pH3. Who's in the center? Uniqueness says P. H is all around it. P has 5 valence electrons it's bringing to the party. H has 3, so it's a total of 8. 2, 4, 6, 8. 3 bonded atoms, 1 unshared pair. So again, that's tetrahedral arrangement, but trigonal pyramidal shape. Remember, tetrahedral arrangement just means that this plus this equals 4. Trigonal pyramidal shape leaves us with a 107-degree angle. Let's put that up here, 107. Cool. And take a quick look at this one. See if there's anything on here that maybe skip number 15. We're not ready for that yet. I think the rest of these will be good practice for you. So you should do 9 through 14. I'll put the answers up on Canvas. And that should be enough to prepare you for the test. Just keep in mind that flat things have angles. On paper, they look flat, but they're not necessarily. So work 9 through 15. I'll put 9 through 14. I'll put the answers up there on Canvas before the end of the period. And on Monday, you guys will just take the quiz, the quick quiz. Have a good weekend, guys. Take care of yourself. If you have questions, by all means, stick around.